So we're going to begin talking about the composition of functions, and it really is going to lead us into a discussion of particular types of functions. But we want to talk about what does it mean to compose two functions. And so a composite function is created when you take two functions and you combine one as the domain of the second. In other words, you make the range of the first function the domain of the second function. And that sounds a little funny, but basically what it means is that you take one function and you plug it into the other one. You substitute it out for x. So if you look at h of x as a function, a composite function, it becomes f of g of x. Okay, that's how you say it. And if you look at an example, just a simple one, we have g of x is x cubed plus x squared, and we have f of x is 2x minus 5. So what does this actually mean, this f of g of x? And what it means is you're going to take this function, so the x cubed plus x squared, and you're going to put it in here for x. Okay? So it's similar to, you probably are used to this notation, f of 2. You say, what do you do with that 2? Well, you put it in for x, so you get 2 times 2 minus 5 equals 1. It's the same idea, except instead of replacing x with a number, we're replacing it with a function. Okay? So we're going to take our x here, and we're going to write in 2x cubed plus x squared. Okay, we're going to replace the x with x cubed plus x squared, and then you can simplify. Okay, so 2x cubed plus 2x squared minus 5. And that is f of g of x. Okay, if you want to do the other way, you say, what's g of f of x? Okay, well, you are going to do the exact same thing, but this now, this 2x minus 5, is going to go in over here wherever there's an x. So it's going to go in two places. It's going to go in the x cubed, and it's also going to go in for the x squared. So you're going to get 2x minus 5 cubed and 2x minus 5 squared. So all you're doing is replacing the x with the new function. And then you could simplify that further if you wanted to. I'm not going to. But that's the idea of composing functions. Pretty simple in terms of understanding what you're doing. We use it in a number of different contexts, particularly in calculus. When we're finding the derivative, we're going to use f of x plus h. So we have to kind of understand what that is. But in terms of what you're going to do with this, if you're looking for g of f of x, all you have to do is take f and put it in for the x in g. So all you do in this case is you say g of f of x is 2 times, and then instead of x, which is in our g, we're going to put this, x squared plus 3. And then times, sorry, not times, plus 5. And then you're going to simplify. So simplifying just means you're going to get 2x squared plus 6 plus 5. You're just going to multiply the 2 in to the x squared, and 2 times 3, and then that gives you 2x squared plus 11. Okay, that's the idea. So let's do another example. Here's an example. I'm going to get rid of these, and we'll go through them together. But f of 1, when you have a number, you're just taking that number and replacing it in the function f. So the function f is 3x squared minus 7. So it becomes 3 times 1 squared minus 7. And that's 3 minus 7, and that's minus 4. If we're doing f of g of x, then we're going to do, again, we're going to take the x out of here and put this in its place. So it becomes 3 times x squared minus 5x plus 1 squared minus 7. And I'm going to leave that like that. I could expand, but it's not going to make it really any nicer. So I'm just going to leave it alone. Then it says g of h. So we're going to take h, x cubed minus 2, and we're going to put it into g. So g is x squared first, so it becomes x cubed minus 2 squared. And then minus 5 times x. Now that x gets replaced again with an x cubed minus 2, and then plus 1. And again, we could simplify. I'm going to leave it alone for now, because I just want to sort of show you this is the process. You can simplify, and you should simplify. But for our purposes, I just want to sort of get you the idea that the x is getting replaced by the function. So if I have h of f of x, then I'm going to take h, which is my x cubed minus 2, and I'm going to replace the x with f, and f is 3x squared minus 7, so it becomes this. Okay, typically, we're not going to simplify things that are higher than 2. We're not going to do anything more than squared. So if you have cubed or something like that, you can just leave it alone. Okay, and then if I want this one, whoops, sorry, clicked the wrong button here. If I want f of h of 1, then what we're going to do with that is we're going to figure out what is h of 1, first of all. Okay, so h is x cubed minus 2. So I'm going to get 1 cubed minus 2, and we're getting that x cubed minus 2 from up here. That's where we're getting that from. That gives me 1 minus 2, and that gives me minus 1. Okay, then I take that and I replace it into f. So now I really want f of h of 1 becomes f of minus 1. So what does that give me? Well, f is 3 times x squared minus 7, so it becomes 3 times minus 1 squared minus 7. So that gives me 3 minus 7, and that gives me minus 4. Okay, so that's the idea. We're going to replace the h of 1 with what it equals, and that becomes what we're plugging into f. All right. So here's another example. It says f of x is 2x plus 8 and g of x is 3x minus 2. First thing it asks us to find is f of g of 1. So I start out and I say, what's g of 1? So g of 1 is 3 times 1 minus 2. So that becomes 1. And then I take f of that value. So that 1 goes in for f. And that becomes 2 times 1 plus 8. And that is 10. The second one says f of g of minus 2. Same idea. We're going to take g of minus 2. So that gives me 3 times minus 2 minus 2, which gives me minus 6 minus 2, which is minus 8. And then I'm going to take that and put it in to f. So I'm going to get f of minus 8. And that is going to give me 2 times minus 8 plus 8, which is minus 16 plus 8. And that gives me minus 8. And then the final one is a little bit different. It says f of minus 1. So you're going to start out and say, what's f of minus 1? We start with that inner piece each time. So we go 2 times minus 1 plus 8. And that gives me minus 2 plus 8, so 6. And then I'm going to take that and put it into f a second time, because the outside function is also f. So f of minus 1, we find that first, and then we're going to do f of that value. So f of 6 becomes 2 times 6 plus 8, and that's 12 plus 8, which gives me 20. So my answer is 20. Okay, and we'll just put a box around each of our answers. But the process is the same each time, and I think you can see that. Now, we could talk a lot more about composition of functions, but I just am trying to get you a general idea. It's not something you have to know a whole lot about, but you should notice that what happens is we plug an x value into this function. That's the domain of the first function. It then gets translated into a y value or a range. So it's going to give me a range. It's going to give me a list of y values. Those y values then get put into this function. That's the second step, right? So when we're talking about domain and range, we're saying the range of the first function, that is the y values that are produced by g, become the x values in f. That's what we mean by domain and range. Okay, so the domain of the second function is the range of the first function. Okay, so here's another example. It says find f of g of a. Well, we have to first of all then find g of a. Well, what's g of a? It's just a replacing x, so it becomes a squared minus 1. And then that gets put into f. So we want now f of a squared minus 1. And that is going to give me 3 times a squared minus 1 plus 4. So that if we simplify that, we get 3a squared minus 3 plus 4. And so our final answer is 3a squared plus 1. That is f of g of a. Okay, the other way around, you're going to start by saying f of a. What's that? So we go, okay, well, that's 3 times a plus 4, because we just replaced the x with a, and then we put that into g. So now we're going to say, what's g of 3a plus 4? And that is going to be 3a plus 4 squared minus 1. And if we simplify that, it's going to become 9a squared plus 24a plus 16 minus 1. So it becomes 9a squared plus 24a, oops, change that again, 24a and then plus 15. And that is our g of f of a. If you're wondering where this came from, it's just this squared, and then 2 times this times this. That's what I'm doing. It's just a perfect square, all right? Same thing down here. You notice that f of x and g of x, though, in this question are the same. They're both x squared plus x. So when I say f of g of x, that's going to be x squared plus x squared, because I'm taking this, x squared plus x, and I'm putting it in both here and over here. So I'm putting it into the x squared first, and then I'm saying plus x, and x is going to be x squared plus x. All right? So what ends up happening, that becomes x to the fourth. This becomes x times x squared is x cubed, so 2x cubed, and then plus x squared, because that x gets squared, and then you're adding another x squared and another x. And so the final total is x to the fourth, 2x cubed, and then there's 2x squareds, and then an x. All right? Now, I'm going to just say that's also equal to that. We don't have to do it twice, because g and f are the same function. They're both x squared plus x, so they're both going to give us the exact same answer. All right? So that's a little bit easier to do because you don't have to do anything. It's already done. Okay? The other way that you're going to see this written, just so you know if you see it, is f of g. It's like an O, a small o is the idea. So it's saying f of g, the o coming from the of, I guess, but it's f of g. And if you see it the other way around, you would also see it g of f. Okay, where this is actually supposed to be an open circle, g of f of x. All right, so if you see this notation, it just means this. It means f of g. If you see this notation, it's g of f, and the process is the same. F of g, you take g and you put it into x, so you get x squared plus 2 all cubed. But it's just a different way of writing the same thing. So you'll see Fogg and Goff, if you want to remember it that way. Okay, so just to show you what that looks like in terms of mathematical notation, it's written out a little bit nicer. So we have f of g of x. So what we're going to do is we're going to take g of x and put it in for x. All right, so we take x squared plus 2 squared, and then x becomes x squared plus 2, and then your minus 6 stays the same. If you do it the other way around, g of f, it means you're taking this and you're putting it in here. And so you're going to end up with x squared plus x minus 6 all squared plus 2. So that's the idea behind composite functions. All right? And I mean, there's a number of different types of functions you can have. So here's another example. It's root x and x cubed minus 8. So if I say f of g, that means I'm taking the square root of, instead of x cubed minus 8, because that's what g is. If you're doing it the other way around, you're taking the square root of x cubed minus 8. Okay, because you're taking f and x. So it's very much the same process over and over and over again. It's just a matter of the functions might be different. So if you say f of g of x and g of f of x here, function's a little bit different. It's 1 over x. So f of g becomes 1 over, instead of x, it becomes 1 over g of x, so 1 over x squared minus 3. If it's g of f of x, you put, instead of x squared, it's 1 over x squared, because f is 1 over x and it's being put into g. All right, so that's the idea of composite functions. And really, all you're going to do with this is find f of g of x and find g of f of x given two functions. Or, if you jump back up here, we did a couple of examples where you're going to actually find f of g of some value, or g of f of some value. So you're either going to get a number, or you're going to get a different function. But that's all you have to know in terms of composition of functions for what we're going to use them for. So we're going to do a little quiz, and we're going to move on.